Alright, we're on the final exam practice. Question number 1, part G. In this question, we want to evaluate this indefinite integral, integral of square root of quantity 4 plus x squared with respect to x. And so as we're looking at this integrand, we notice that we have that particular form, square root of some number squared plus our variable squared. And so this should scream to us to use a trigonometric identity. And so we'll just have to remember which one to use, but in fact, in this case, we're going to use x is equal to tangent theta, but not so fast because we need a 2 in front. Because when we square this, we want it to have a coefficient of 4. So either way, let me just calculate dx, just so I don't forget to do it. So this is going to be 2 secant squared theta d theta. Okay, and so now we want to go ahead and simplify this integrand, so I encourage you to do this every time. So simplify square root of 4 plus x squared. So 4 plus x squared, x is now 2 tangent theta, so when I square it I'll get 4 tangent squared theta, and then square root. Okay, I have a common factor of 4, so I'll pull it out, but I take the square root, so it comes out as 2, and then I have square root of 1 plus tangent squared theta. But 1 plus tangent squared theta, I can use my Pythagorean identity that tells me this is equal to secant squared theta. And so since I have secant squared under the square root, and the values of theta that I'm using here, not that you need to worry about this, but they will make secant positive, so when I take the square root of the square of secant, I'm going to get just secant back. Okay, so this simplifies our integrand, and now we just need to combine everything. So our integral is square root of 4 plus x squared with respect to x. Okay, I do my substitution and rewrite everything, so I get a 2 secant theta from the square root of stuff, and then from the dx I'm going to get a 2 secant squared theta and d theta. Okay, now that we're at this point, we can go ahead and combine everything in our integrand. It's just a product, right? So this will be 2 times 2 is 4. I'll just pull the 4 out front. Not really gonna be a help or a detriment. And then I have 1 factor of secant and then 2 factors of secant, so I have secant cubed theta d theta. And so now I just need to recall the antiderivative of secant cubed. Okay, and it turns out to be 1/2 times quantity secant theta tangent theta plus natural log of absolute value of secant theta plus tangent theta. Alright, and then we're done with integration, so we go ahead and add our constant so we don't forget it. Of course, you'll notice that we are in the wrong variable completely. We need to be in the variable x to get our final answer. We're in the variable theta. We know a very easy relation between tangent of theta and x, so we can just rewrite that to remind ourselves. So we have x divided by 2 is equal to tangent of theta. But now we also need the value of secant of theta, so we'll go ahead and draw our triangle to get this value. So let's just call that angle theta. So tangent is opposite over adjacent, so this is going to be x over 2. The hypotenuse by Pythagorean theorem is going to be square root of x squared plus 4. Okay, and so now I need to write down what secant of theta is. But secant of theta is hypotenuse over adjacent, so this is square root of 4 plus x squared over 2. Okay, and now I just need to combine everything. So first of all, I got a factor of 4 and 1/2, so that'll just leave me with a factor of 2, right? Go ahead and just get rid of that 4 and that 1/2 and replace it for 2. So then I have 2 times secant times tangent, So 2 times secant I now know is square root of 4 plus x squared over 2. Tangent I know is x over 2 plus 2 times natural log. We got to distribute that 2 to both terms. So 2 times natural log. We know that secant is square root of 4 plus x squared over 2. And we know that tangent is x over 2. And that's it. And then we just write our constant. And we're basically done, but now we can simplify a little bit. So we can cancel some 2's. This is going to be just x times square root of 4 plus x squared over 2 plus 2. Okay, and so now we can do some trickery, and they do this in the book, and you can check the back of the book, because you'll see that when they integrate something like this in a reference table, they actually don't end up with these terms in the natural log. They'll actually remove this factor in the denominator, because we know that when you have natural log of a quotient, you can always separate that as natural log of the numerator minus natural log of the denominator. So essentially I'll get rid of, a minus 2 natural log of 2, right, coming from this denominator of 2, and then I'll absorb it into my constant. And so what I'll write this as, not that this is super important, but either way it can be done. Right, so I just get the numerator there plus the numerator of the other term, plus now I have some new constant. I'll just call it C prime, just so you know C and C prime are actually different, but either way they're both still just constants. And this is our final answer. Alright, cool. That finishes this problem for us.